Okay, Adams Control Braking Diagnostic System. Uh, so we have emergency system configuration, auto brake valve system run lap, reach run lap application emergency shows the. Let's see if we can't zoom in here. Automatic brake pressure for a WG4, WP4 locomotive, 113.78 psi to 142 psi. Release of release is brake pressure, running emergency brake pressure, running emergency and brake, minimum service, emergency and brake pipe reduced, full service reduction, brake pipe reduction, emergency reduce, brake pipe reduce, brake pipe reduce less than 14 psi, and then some of this is these are the computation brake charge, emergency pressure, direct brake charge, emergency pressure, release position, brake pipe 0 PS for Elka locomotives and GE. Then this is a fault bin application where it takes the fault of the arrow in the directory and sends an error code to the fault pin, which is later used for printing at the end of the day to get all your entries on where you faulted. This is the air brake self-test, check driver, locomotive speed sensor valves, handbrake applied, locomotive isolatedly cut in control, active brake handles, inactive controller, brake valve handle full service, main reserve, brake pipe exhausted, brake pipe fully charged, brake pipe value less than fully charged, and your air brake self-test is always a reset for the system, so then load high brake pipe system, stay resident, air brake test, pass, emergency code, emergency execute, reset, yes or no, automatic brake valve duration 60 seconds with automatic brake valve and runner release. Then it goes over some more system operating pressures for automatic brake valves. This covers 3 different controllers. Number 1 controller, air brake self test. This one would be controller 1, sensitive greater than 100 hertz, automatic frequency greater. Show the arrow code, independent handle frequency less than 100 hertz. Warning, no control number 1 space. So you have to turn either control 1 or 2 on. Control N3 is in the back. Same series shows the air brake self test when the fault code is to clear with a passing air brake fault test. We have lead trail switch. Which is air brake control number 1 switch to air brake control number space. Whether it's inoperative, controller number 1, number 2, and number 3 would be inoperative, while controller number 1 is default. Air brake self-check driver, cutout relays. This one's the cutout relays. Less than 808 hertz. Automatic frequency vault code 2. Time dated and stamped, faulty wiring, faulty controller, or fault 1, fault 2, faulty wiring, air brake control number 1 failure, switch control number 2, you can also switch controllers in between these. This one shows automatic brake handle frequency high, and then it shows the diagnostic code. Let's see, automatic release switch stuck open. And shows the arrow diagnostic code is automatic release stuck on open bat, and they're running at Hurst delay counter system greater than 2 seconds. Warning, automatic release switch is stuck as open, and then automatic release switch stuck closed. And then we have some more automatic emergency switch stuck open. See controller 1 automatic emergency switch stuck closed bat, and that has the different running systems: emergency switch, controller 1, automatic handle, delay counter, cutout relay, and brake pipes system. Your independent handle frequency low. Independent handle frequency high. That's a controller, computer controller brake executed. Independent release switch stuck open. Independent release stuck closed. Independent max switch stuck open. Independence equal to or below 3,208 horsepower. 3,218 horsepower delay counters. Timestamp sent to trouble execute number 1 to the open text viewer. So you can you look at your faults at open text relay. The fault code would be cleared with the independent handle in the full position. Then we show independent max switch cutout, and just briefly going over these independent other than full position. And then diagnostic code 2 bail off switch stuck closed. Number 2 controller, pretty much the same as the first one. They should be all the same. Automatic handle frequency low, automatic handle frequency high, switch stuck open, switch stuck closed, and then we'll just scroll through some of these other ones. We'll get up into so there's your diagnostic code. This would be a bail off of the air brake failure switch control number 3. This is 225 pages of script, main reservoir pipe transducer system, and fault code, main reservoir equalizing pipe transducers, defective emergency reserve transducers. So this covers the whole brake system, and it's no emergency emergency response, no emergency exhaust, and then let's see if I have the piping diagrams in the back. They should be in the back. Let's look at this one. Number 20 supply shows 20 reserve analog converter reserve, supply magnet, 80Z board, 20 reducer, lead trail, brake equalizing, automatic equalizing magnet valve. So this is a triple control stand brake system, and it's very extensive. You can see here they list the lead switch controls deactivated, switch open, lead controller switch, and failures. Then it gets into some of the braking systems. Let's see where we start. I got the original drawing spec from the air pressures from CCCB maintenance manual. This shows your brake valve controller and pneumatic control. This was actually CCCB Indian Railways maintenance manual, and I turned it into a computer program. And this one shows an extra seat for another brake control valve for a third one. This might not exactly be the same file. And then it goes over the hydraulic relays and the brake pipe charging flows indicators. So all the charts are here for the brake pipe and the locomotive and pneumatic. Then it has these failure tests, serial number test preparations, and shows you automatic good working order. And that is a quick glance at the Adams Computer Controlled Braking System Diagnostic MS-OS Diagnostic, written in Adam Nugent Rosenberger on April 2nd, 23rd for triple control stand locomotive.